Hi, welcome back to Math Extra. My name is Mr. Leichner, and I'll be your 7th grade teacher today. And I'm a math person. And remember, just like we've said every week, we're all math people because math is everywhere. Now this is going to be the last week I see you for a while, but all summer and all next year, remember, you are a math person. So let's get started, 7th graders. Let's do this. Let's do the math on Math Extra. So 7th graders, today we're talking about my favorite topic in math, seriously. And actually it's one of the most important topics because there are actually over 1 million jobs out there in this field alone right now. It's called probability. If you know probability and statistics, it can help you in life, it'll help you in your job. For example, there's a probability that the Hornets will win the NBA championship. It might not be that big a probability, unfortunately, but it's a probability. They're also using probabilities now to figure out when the state can reopen with the coronavirus. I know it's really tough. We don't want anybody else to get sick, but we also want to make sure that our economy can do better. So they're kind of weighing the options using statistics and probability. It's that important. So what probability is the chance that something you want to happen over the total number of chances, or divided by the total number of chances. For example, a lot of you, I'm sure you've heard of flipping a coin, right? To see if something's gonna happen or not. Now a coin has 2 sides. It's got a tails and a heads. So there are 2 possible outcomes when you flip a coin, heads or tails. We're gonna try a little experiment and see what happens, see what the probability is of getting each one. So, you're probably not gonna be able to see the actual results, you're just gonna have to trust me, but I promise I'm really, really honest. All math people are honest. Heads. I'm gonna write these down so we can use them later, but we'll come back to that in a minute. Heads. Tails. Tails. Heads. Heads. What do you guys think's gonna be next? Got a guess? It's random. Heads. Tails. That's 8. We got 2 more. Is tails gonna make a comeback? Heads. And last one. Heads. So what we ended up with is 7 heads and 3 tails. Now, we had 10 total chances. So we could say our probability of flipping tails was 3 out of 10. The fraction, 3/10. Now we could also write that as a decimal, 3/10.3. We could even write it as a percentage. Remember when we did those 100 boxes? You probably did them with your teacher. That's 30 boxes out of 100, or 30%. Now for heads, that's 7 chances out of 10, or 7/10, as a decimal, 7/10, or 70%. Now, I want you to think about something. If we think about that, 3/10, 7/10, 30%, 70%, do you notice any relationship there if we added them together? It's gonna equal 100% or 1. Remember, 100%, that's 100 parts out of 100, so it's really 1. So let's take a look. The total for any probability is going to equal 1. Hopefully you can write it neater than me too. But either way, it's going to be 1. The total chance, because something is gonna happen. Either you're gonna flip a heads or a tails. But you're not going to flip neither one. You're going to flip one or the other, so it's a 100% chance of one of them happening. That's experimental probability. That's what actually happened. Now let's think about it more theoretically, what we would expect to happen. If we have two options, you know there's an equal chance of each one happening. I could flip it, and it's either going to be heads or tails, but it's about an equal chance of it happening. How much of the time do you think it'll be heads, and how much of the time do you think it'll be tails? About half. So, if we think about what the theoretical probability is, out of 10 chances, you would expect to flip tails 5 times, or a probability of 0.5, or 50%. You would also expect to flip heads 5 out of 10 times, or 0.5, or 50%. Now, what's really interesting about that, so our experiment came out different. We only flipped it 10 times. But if we flipped it another 10 times, it might end up being the reverse. If we kept flipping it, if we flipped like 1,000 times, it would end up being really, really close to our theoretical probability, because the more times we do it, the more it's going to get closer to what we expect. So now, we're going to think about what happens if we have more than one thing happening at a time. So if we flip a coin, we know we have 2 options. But let's say we roll a die. We have 1, 2, 3, 4, 5, 6 options. So we have a whole lot more chances. When we flipped our coin, remember we only had 2 chances before, heads or tails. We had tails, heads. Now we have a whole lot more total chances. How many? Let's figure it out. So what's the probability that you flip a heads and roll an even number? Remember, an even number ends in 2, 4, 6, 8, or 0. So we'll use that. Now, if we're going to figure out how many total chances there are, we're going to try making a tree. So our first tree has 2 branches for tails and heads. Now, once we flip a tails, we're going to roll the dice, and we have 6 possibilities there. 1, 2, 3, 4, 5, 6. What are those possibilities? We could roll a 1, 2, 3, 4, 5, or 6. Same for heads. We could roll 6 different numbers. Not the neatest tree, but we'll deal with it. 4, 5, 6. So now we need to look at our question. It said the probability you flip heads, so we know we're looking at this side of our tree, and roll an even number. So 2, 4, 6. That's 3 selected chances over how many total chances? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3 out of 12 is our probability that we're going to flip a heads or roll an even number. And you know that simplifies as a fraction to 1/4, as a decimal 0.25, or as a percent, 25% chance. Now, does that mean that that's always going to happen exactly 25% of the time? No. Think back to when we flipped a coin. But over the long haul, if we did this 1,000,000 times, we would expect it to happen 25% of the time. Now let's look at a real-world example of probability. Now, when the cafeteria managers in your school need to figure out what kind of food to order that everyone's going to actually eat. So they might need to figure out what type of options to offer. Let's say kids can choose a hamburger, cheeseburger, or pizza. They also get either, sorry, I'm gonna go purple, an apple, a banana, or an orange. And for a drink, they can choose either milk or juice. So how many options are there? Because if we know how many options, they can figure out how much to order. So let's say someone gets a hamburger. Then they get an apple. Then they get a milk. Ham, that's our first option. But let's say they get hamburger, apple, juice. Second option. Now I'm gonna organize these by making a list because that's gonna keep it so that I don't forget any. So we've got hamburger, apple. Now we're gonna go hamburger, banana, milk. I'm gonna write in all the same color now to make it easier. Hamburger, banana, juice. Hamburger, orange, milk. Hamburger, orange, juice. So if for any kid that chooses a hamburger, they have 1, 2, 3, 4, 5, 6 options for lunch. Now since they can choose a hamburger, cheeseburger, or pizza, they're gonna have 6 options for a cheeseburger, 7, 8, 9, 10, 11, 12, and 6 options for pizza, 13, 14, 15, 16, 17, 18. Now if you wanna see listed out, it'd be cheeseburger, apple milk, cheeseburger, apple juice, pizza, apple milk, pizza, apple juice, and keep going. But total, there are 18 options. Now, we're gonna look for a quick relationship. Before, when we were thinking about our flipping a coin and rolling the dice, we had 2 options for the coin, 6 options for the dice, and a total of 12 options. Do you see a relationship there with 2, 6, and 12? See it? It's not plus, it's not minus. Multiplication. If we multiply the total options, 2 times 6, it gives us the total options, 12, which is the same thing that we got right there. Same thing for the cafeteria. 3 options for the meal, times 3 options for our fruit, times 2 options for our drink. And you want to take a wild guess what it's going to give us? 18. So if we multiply, if each option has the same probability, we can multiply those total options, or multiply the number of options for each one and get the total number of options. Now you're going to see how we can make some money on it. Now, I know most of us are too young to play the lottery, but I'm still hoping to win one of these days. Now, in the lottery, some of you have probably seen, you can win sometimes even like $700 million. I think that was the highest one I played last year. You have to pick for Powerball 5 numbers right out of 69 and 1 other number out of 26. So if we're thinking about how many total options there are, how many total options. So for each number out of this big part here, there are 69 options. Now, I wanted you to think about something. Will it be 69 options for each of those 5 numbers? Because we're going to start with 69, but one of those is going to be right. So when we take one out, how many options are there for the next number? 68. So it gets a little easier to win. 68. And remember, we're multiplying because we're looking for the total options. Times 67, times 66, times 65. So those are our options for that one number. Now for that bonus number, there are 26 options and we only have to pick one of them, times 26. That's our total number of options for winning the Powerball. Now, it might not look like very much. 69 times 68 times 67 times 66 times 65, that's not that high numbers. But when you multiply, it's gonna get pretty high. Use my trusty Math Extra calculator. 69 times 68. Already, we have 4,692 options just there. Times 67. That's going to be 314,000 options. Now, I'm not going to go do the rest of the math. You can do that at home if you want. It's pretty interesting, but it ends up being over 300 million options. So that's how the lottery can make some money from you just picking a couple numbers and paying $1. If enough people pay that $1, somebody's going to win. But if not enough people pay that $1, all that money goes to the lottery. That's how they can make money, and actually make money for education. It's the education lottery, so we'll take it. Last but not least, we're going to talk about a very, very important probability concept to me, candy. I used to bring candy to my class all the time. I love Jolly Ranchers. They're quick to eat, they're not overly unhealthy, and there's lots of different flavors. So Jolly Ranchers, you can get cherry, watermelon, green apple, blue raspberry, and grape. And I made the kids pick randomly. I wasn't gonna be the guy that was like, oh, I'm gonna give you this and you this and you this, because that becomes a big pain. But there were a lot of kids that couldn't stand grape or green apple. So what's the probability they picked a flavor they liked? So if we take a look at our problem here, it says that there's a bag of 50 Jolly Ranchers. So that's our total options, 50. Now, to get a flavor they liked, we are taking out oops, we're not taking out Jolly Ranchers, no way. We're taking out grape and green apple. So there are 10 green apples, 8 grapes. So 50 minus 10 minus 8 gives us 32 Jolly Ranchers that we want. 32 out of 50. So our probability there is 32 chances out of 50 that they're gonna pick one they want. Now we're gonna get a little more mathematical with that, because that's not that easy to think of. Like, is 32 out of 50 good? Is 32 out of 50 not a good chance? So let's take a look. Let's do it, reduce that fraction. 32 over 50, if we divide the top and bottom by 2, it'll give us 16 chances out of 25. A little easier to tell. But now let's make it into a percentage. Over 100. So 25 times 4, 16 times 4, 64 out of 100, or 64%. So there's a 64% probability that our kid's gonna like the Jolly Rancher they pick out, and that's a pretty good chance, especially when the teacher's just being nice, bringing it in for free. So I hope you learned something today about probability. It really is my favorite math topic because it applies to so much stuff in the world, especially sports, but then even things that are more important. Now, one more thing I want to bring up. A lot of the jobs out there that involve probability and statistics are called actuaries. And what an actuary is, they work for companies and figure out things like how much a store needs to charge for something to make sure that people will buy it, or how much an insurance company needs to charge based on the probability that they're going to collect money from the people that are paying the money. Now, a way to go learn more about this is www.beanactuary.com. And it's just something really interesting to learn about. If I had known what an actuary was when I was younger, I might be one now because I think it's fascinating. So I just want to make sure you knew about that. Now, coming up next, we have Mr. O'Neill with something really challenging and fun for our 8th graders. Thanks so much, and remember, we're all math people. Stay safe.